5 in downtown Jose. Okay. A couple of housekeeping things. Your lab books were finally completely marked. I went through all of them, looked for your table of contents, your purpose, your diagrams, your observations in every single table, and your overall neatness and organization. To make it easy for me to give back the feedback, I didn't write all over your book because I needed to collate it. So I just put it on a multiple choice sheet and then scanned that in. So I've just released that, and after this you can go and take a look. So if I, for example, was looking at your table of contents, if I scribbled in an A, that means it was thorough and well organized. You had subsections, it had all the stuff you could possibly need. B was essentially all of these go from extending, proficient, developing to absent or not yet emerging. And then minimal, you've got a table of contents. It's not complete, but it's there. Purpose. If you read through the whole lab, the lab was to do neutralizations for acids and bases, identify 5 unknowns. It was also to show how indicators worked. It had 3 separate sections. If you addressed all of those sections, then you had A, extending. B, if you had at least a couple of those, and then C, you had 1. C would be like, the purpose is to investigate acids and bases. Diagrams. There were some fantastic diagrams. One thing I would like to do after this is go through. I want to take out all the ones that were the best and take little pictures for future years. Some of you made some really fantastic ones. Testing solutions with litmus, adding phenolphthalein, zinc test setup, and then part 2, mixing A and B. That was sometimes in part 1C, depending on whether or not you had one of the procedures that was corrected or not. For the one where you mixed it, one of the things I'm looking for, no, I'll get to that in a moment. So for all the diagrams, if you were having less than extending, you either needed more labels or better drawing ability. So either I needed to know what more things were, or some people got away with very few labels because their ability to diagram so clearly communicated without labels, it was fantastic. And some people just labeled really well, and it was awesome. So if you're looking where to improve in there, that's probably the areas. For myself, with my drawing ability, I label everything 10,000 times because nobody can read anything that I draw. But some people have better talent than I do. Are there labeled diagrams for each required section? A, B, C, extending, proficient, developing, and so on. Go to the next one. And then a sample table. So table 1. Tables need titles. So one thing that's not on here that I was looking at would be that you have something like table 1, an examination of litmus and acids and bases. Correct results going through. You should have had bubbles for the H2 gas, and it should have been a surprise if you did not. We've done that observation in class. We've mentioned it in notes. And then there were a few that say, in the base said, it was bubbles. I guess bases react with metals and produce bubbles. And that is in no way true. Did you record the color changes? A, B, C, D. Table 2, this is where you mix them together. So if you had a purple solid residue that went kind of brown and stunk, that means you added way too much phenolphthalein. So that is a little indicator in the lab of your lab technique, and that gets reflected in there as well. If it was a white powdery solid, like a few of you got, then you used just a drop of phenolphthalein as it instructed you to, and you did well. But you should have had some sort of powder in there. The third table, all of your unknowns. So first of all, you're getting kind of the correct results. You're getting, and then I have made a very simple one because I'm using this for marking. But one I mentioned in comments quite a bit is there's a lot of no change. And so if, like the zinc test, if it says no change, what does that mean? No change from what? What was your starting conditions? Do you see it in there? Is there a couple bubbles from when it dropped in and you didn't see any more? No change itself isn't an observation because you haven't said what the previous state was. So you need an observation of what you see, not just that you don't see anything changing. That's a verb, not a noun. Acid, neutral, base, and then a weak acid for Alka-Seltzer. Perrier caused some confusion because many of you did get, like, red litmus stayed red and blue litmus stayed blue. If it's an acid or a base, it should not do that. The only thing that could do that is a neutral thing. And those of you who got that, it's very clever, well done. And then overall neatness and organization. Now, your tables could all have been, there's some criticisms, maybe I'm giving you B and C, but your neatness was outstanding. And so this doesn't always correspond with this, just to explain. And sometimes, like, your tables are fantastic, but you lost on neatness because overall, you got to use a ruler, things have to be placed on the page appropriately. One person made a separate table for every single column, and that was just really hard to read. So I went through and did this in detail. You've had lots of feedback before this formatively on the labs. This is what you need to improve, this is what you need to improve. So this one is marked, it's summative and in. We are going to put in more labs. I am going to put in the 2 labs you've done on sheets of paper. And then you are going to have another one, at least in physics, if not in biology, in which we do the rocket lab, and you're going to come up with your own procedure. Well, lots of it are fixed, but you're going to put it into there and record your results, and I'm going to look at it as a formal lab, so you're going to take all of this feedback and improve on the next one. Improve on the next one, that I can change that mark into the next section. And the 2 little ones, I might be able to improve it as well. So that is where that comes from. I also wrote a little comment while I was going. I didn't want to write it in your lab book. So I wrote it in an Excel spreadsheet because that's always better. But then I realized I have to get that to you. So I printed it out 1 row at a time. So I'm also going to hand you back a little comment. If you would like to go on and double check, you should be able to check on ZipGrade the scanned results, so it'll tell you for each one, did you get A, B, C, or D? And you should have this linked there as a PDF. Yes?
There's not like DNA quiz posted.
Pardon?
Our DNA quiz that we did like a while ago.
Yeah, that's coming back. But I'll mention more about that in a moment. Right now, if you want to go into ZipGrade, make sure you can access it. Because it'll make sure you can. When I call your name, come up and get your comment. Jaden. Jessica.
My lab was so bad.
Jaden. Jessica. Natsuho. Isaac. Charlie. Oh, see me after. I can get that. If we have time in the class, I'll get it to you. Key. What? Fiona? Is this the wrong class? Hold it. I've got C block and Pablo's not in this class. Chan's not in this class. Darren, Jojo, Zachary, Julian PD, Andrew Stevens, Riley, Anna, Lucas, Liam, Caden, Oliver, Jennifer, Hillary, Mick, Esther. Now we should be Sterling. I read them very quick to make sure. They are intended to be quick comments. But sometimes I write words that are not appropriate for class. I have to double check those. Well, in one grade 12 one I wrote, that was a really effing awesome table. And then I had to go edit that. I got ChatGPT. Katie?
You have
Isabel.
our zip grades if we lost them.
Pardon?
You have our logins if we lost
I
them.
do. Joe, see who? Tyler. Ariel. Sorry, yours is down. Thank you. Aria.
I didn't do table. I
Alexander.
got everything else right.
Ha. Alphabetical order name given last. Fitting.
Dude, all I need is my
And then
my
Rose,
identity.
any more of these?
I forgot that.
Okay. You should be able to see. Is everybody able to click on a PDF that gives you that? So you can see? Student ID I can give you after. I can't. I want to get started, so I won't give you like the second. But see me after. I can print off. I can reprint off the PDFs. I just assumed you wrote them down. Okay.
You should have saved to my passwords too.
Which weekend did you get? No. I did.
Really? Wait, no, I want to see mine.
Okay, next thing. Your summative. We have on our calendar that. Oh my goodness, that's a busy calendar.
Is that this Thursday?
So that would be. I put it on the classroom part. Oh, there it is, right there. That would be this Thursday. I am moving it to next Friday. I would like to say that I'm moving it to next Friday because it's musical this week and I'm really nice. But the answer is because I'm incompetent. As you know, I got ill and I still have a pile of marking to get back to you. And so I'm working on that right now. And I want to be able to give it all back to you before you write your summative, because otherwise, why did you do these? If you do better on the summative, the intention, of course, is that these formatives, I can discount those and use your summative as a mark. Now, remember, the summative you won't have your worksheets for it. You have to know things come in. Also, I should probably say a couple words about the quizzes. When you do the quizzes, you have your worksheet. So I assume you have all of your terminology. Just answering things is really easy. And so I'm looking for all the extra stuff you know in there and that you can put down. So if some of your grades in here might be, you may just need to have a chat because you wrote exactly what was on the sheet, but in a way, like it needs to be more clearly communicated. I can show you that when you get it back. These are going to be done very, very soon, and then I'll get on the next ones. But the ones, if you get anything wrong, it's like, well, you had your worksheet. An open book anything is always more rigorous than a closed book anything. Your test will be closed book. Yes, always. Preferably not in your chair. There you go. Move test, gave back, marking, mentioned quiz.
Also the quiz that we did last week, is that going to go into our midterm grade?
The quiz, no, I'm marking that one. I'm not up to that one yet.
I didn't do that one, so do you want
Oh, who has not done last week's quiz?
I wasn't here for the entirety of last week.
Excellent. You can find a spot and I'll bring it to you. Pull out your genetics work. Pardon?
Do you have the worksheet that we did?
Yeah, the worksheet has so a couple of old-timey actors on it.
Which worksheet?
The one that has. You should know.
I wasn't here for the entirety of last week.
Yeah, the worksheet was handed out like 3 weeks ago.
Which one is it?
It's the one that has a couple of heads on the front.
You mean the data book?
No, 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 no. That's not a worksheet. It is. This one.
Oh,
Yeah.
okay.
You know? If you were about to do that, is there anybody else who hasn't done it?
Well, yeah, I didn't do that as well.
Okay, pull out that worksheet. A reminder, when you do this one, there are 3 questions. You only have to do one of them. There's developing, proficient, and extending. Do the one you're most confident with. You can do the rest if you'd like, but indicate which one you want me to mark first. And then other than that, find a spot. And I will bring you a data booklet and the quiz. How many are there? 1, 2, 3.
Oh, yeah. Actually, you have an extra pack, yo. Oh my god, I love you, yo. You want the mutations one?
That's your notes. That's not a worksheet.
No, because you said data book. That's not the worksheet, that's the package.
Crazy, man.
Okay, but do you want us to bring our own data booklet?
No, I just said I'm bringing you a data book. Just find a spot to sit down with your worksheet.
I got 70.
What are we doing?
What do you get?
64.
What do you get with that?
Last one is here. I'll add my favorites. How did you find the student ID?
It's 200 and then 2 numbers after that.
I know that.
You just kind of guess it, I guess.
Yeah, I'm gonna guess 100.
English versus English.
It's socials. It's socials.
Okay. Last day, I gave, when I was away / ill, I gave you this to fill out in terms of mutagens and damage to DNA.
Wait, what?
We
And-
got this.
No, we didn't get that.
We didn't do that.
We got this.
Yeah.
On this.
No.
Okay, but we haven't done it yet.
He didn't.
What?
I think that the sub
What-
last
what-
time did
what-
give us that.
Mr. walked in. He gave us the.
Okay, well, one thing. Biology, we had some of the Jan Cross worksheets.
He gave us the worksheets.
Mhm.
to
He gave
do,
us
like
the
this
worksheet.
class.
Yeah?
No wonder I didn't know anything on it.
Yeah, you would not be able to do it. And he was supposed to instruct you on Did you really?
I don't know. Because I remember asking, I was just like, what's a range?
So you did the quiz,
And they just gave us the.
and then you got the
He gave us
worksheet.
the sheets, and I asked him what a mutagen is, and
Oh,
he said
it's
he
back.
doesn't
I'm
know.
just reading over.
Remember when you said we have limits? And you said, oh,
So you said, too bad for you. I don't know what's going on.
yeah.
Did we have your worksheets?
I don't know, Alex. This is a good question.
Interesting.
Okay, you're
From the time before that class, did you get this one?
I have it.
flexing.
You've gotten that one. Okay.
I'll put it away now.
Okay.
It's triggered.
Okay then. Change of plans. Rather than start anything new, why don't I just go over this, and then I'll give you the rest of the class to work on that worksheet, catch up on any worksheets you need to finish up, and do any studying for your quiz. This is only 2 pages, so it won't take too long. He should have given you a copy of this, or like there was a place you could get it, but it does not appear he forwarded that. So, mutagenic factors that cause mutations. We've done a lot about mutations now. Chemical, physical, or biological. Viruses are part of biological. There's some indication that we contain more viral DNA than mammalian DNA, because viruses will splice themselves into your genome over time, and then if something goes wrong, they stay there. You even use some viral proteins in now in our cell signaling because we've co-opted them. You were more likely to get certain types of cancers if you had a bad flu. You were more likely to get arthritis if you've had a really bad flu. Flus aren't good. I had 2 at the same time. There's 2 types of radiation. Ionizing. You didn't get an email from me that had the PDF attached to it of any kind, or that they didn't forward one to you. I would say that you're lying, but it's all of you, and I feel outvoted. I still want to, though, in the whole, like, I'm a teacher and I can never be wrong kind of way.
Oh,
Yeah. That's why I would
justice.
And then you become a house parent, you know even more why you can't do that.
Oh,
Yeah. Okay. Mutagen, anything that causes a mutation. You can be chemical, physical, or biological. Physical mutagens are things like radiation. And then it's things like X-rays, gamma rays, UV rays. And I want to really underline this. It is not non-ionizing radiation. So microwaves cannot give you cancer. Gamma rays can. So if you stare into your microwave and it is leaking microwaves, you will not get cancer. You may hard boil your eyes like an egg, but you won't get cancer because microwaves cook things, so they can easily cook your eye. The inside, the vitreous fluid of your eye is very similar to the vitreous fluid of an egg. It's the egg. It's essentially egg white, just a different kind. Apparently, seal eyes, eaten raw and frozen, are delicious.
Has anyone ever hard-boiled their eyes by accident?
Yeah, they got microwaved. That's actually a famous accident in the history of science. The gentleman who discovered microwaves built the transmitter because he knew he was emitting some sort of radiation, but he didn't know what. So he had the equivalent of a microwave generator in the middle of his lab just going. And he noticed when he stood in a certain spot, the chocolate bar in his pants melted. So the microwaves were bouncing off walls and stuff, and just like, you know how certain foods in a microwave, especially if it doesn't rotate, will get really hot? That's what was happening in his lab itself. And that's how he discovered microwaves. He then figured out how to put it into a box. The front panel of your microwave, what does it look like? How do they protect you? As a grid. The reason the grid work is because the microwaves are literally larger than the grid. Microwaves are big, and they can't fit past that grid. So the reason they can't give you cancer is they're too big to hit the cell bonds and cause a reaction, and so they're not going to introduce a mutagen. They will just cause it to vibrate a lot, which is heat, which will cook it. Yes?
Why doesn't your eye cook while like tanning?
Because tanning is not well, the tanning part is ionizing radiation, and that will give you cancer. Your eye could cook. You can get a sunburn on your eyes, but it takes a lot more. Your eye would be red sore. Maybe the lens would start to peel if you did it badly enough. Yeah, that's why you have to protect your eyes when you go on suntan. Yeah. So you also cannot get cell phones. Just to be, well, I'm going to go all the way down here actually and do it. I've given you a spectrum here. Katie? What, your laptop, sort of. Microwaves are here. You can cook stuff with this. So one of the, what did you do in physics last year? Have you done wavelength? Okay. This distance, if this is light, that is lambda, which is just the wavelength. And there's nothing special about that. I've had students ask, like, what does wavelength mean? It's the length of the wave. And this side, they are lambda short. And on this side, the wavelength, lambda long. And by long, we're like whole meters, like long. So microwaves, they're like a little bit bigger than the grid that you can see on your microwave. They're fairly big. Radio waves are like whole centimeters big lambda, really big lambda. These can induce currents in wires when they hit the wire, but they can't give you cancer because they're not going to break a bond. They're too big to break a bond. Radio waves are things like cell phones, which is why I know you cannot get cancer from your cell phone unless you like eat it and do the chemical way of getting cancer, not the physical way of getting cancer. Whereas here we have ionizing. Ionizing is short lambda, and it's small enough lambda fits bonds. So it travels and hits a molecule. The wavelength is small enough to hit the bond itself. That bond vibrates, it could break, it could reform on something else. In DNA, a T could change into a G because it's broken, it gets fixed improperly, all sorts of things.
I just wanted to ask if you can go up a bit.
Yeah, no, I'll go back up again. I just went down here so I could explain this.
I have out of curiosity.
Yeah?
If you're like working as a radiologist in the hospital, like you're working with CTs or like MRI, do you like over time develop cancer because you're working with these medical X-rays that are in the ionizing?
Have you ever had an X-ray?
I have.
Yeah, and what do they do while you're getting the X-ray?
They stand out of
They stand out of the room. So if they stood in the room, yes. They stand outside of the room. They let you get the X-ray.
So you get
Wait,
So you get cancer.
So if someone takes
Wait,
enough
what?
X-rays, they can get
Okay.
cancer.
Like
If you get enough X-rays, can you get cancer? Yes. When we invented X-rays, many of the people who got a lot of X-rays, this was invented post-World War II. There's a lot of people with injuries. There's one famous case where a gentleman had bones broken in his foot or leg, and the doctors were trying new forms of trying to get the bone back in and giving him his leg back. He had hundreds and hundreds of X-rays, like multiple X-rays a day. He got cancer in his leg from the X-rays because at the time they didn't understand how X-rays could cause cancer. My parents, so really old people, older than me, remember going into a shoe store and you'd put your feet in a machine and you could see the bones of your toes because it had a screen on top and it was a live X-ray. So you could wiggle your toes and then you'd see if your shoes fit. So people are giving themselves foot cancer just to like fit their feet on there. Now, if you get an X-ray, no, because this is all about dose. So an X-ray, the risk of you like healing improperly is okay. There's a certain amount that they regulate you're allowed to have. You get X-rays just from walking outside, not X-rays. You get radiation from just walking outside and being in the sun. There's some radiation all around you. This classroom, you'll get slightly more than in the third floor because you're surrounded by more concrete, and the radioactive calcium in that concrete is actually irradiating you right now. MRI's magnetic resonance imaging has no cancer in it at all. An MRI is actually an NMR, which is just two acronyms that you're unfamiliar with. Nuclear magnetic resonance is when you take the nucleus of an atom and you put it in a magnetic field, and it vibrates in a very particular way that you can detect. And you can use that to take pictures. I used MRIs, I call them NMRs, to take pictures of molecules. And then they boosted that up in the large scale so you can take pictures of people's heads, but they changed the name because when people heard nuclear magnetic resonance, what did they think? Radiation and cancer, and so they didn't want to take it. So they changed the name to MRI so that you'd feel better about it and you knew it wouldn't cause cancer. But the nuclear just refers to the nucleus. So an MRI does not cause cancer. Now, a comprehensive X-ray, where they do the X-rays all around you, that could, but we use lower and lower power X-rays as our machines get better and better at detecting all the time. So the X-rays you get now are also lower in power than the X-rays we got in the 1950s.
And like, you know, like when you travel and then you stand in that one thing that like X-rays you. Or like you don't have to like go like
Oh,
this.
yeah.
Yeah, and if you travel a lot and you do that a lot, then are you like getting cancer?
Is that an X-ray machine? Or is that a sonic machine? Yeah, there's a metal detector. They now have a high frequency sound. It's like what's that called? A sonogram. Like when you want to take a picture of your baby. It's just an advanced version of that, and you walk into that. And it will. What it does, the sound bounces off you. Some of the sound gets through your clothing, so they can see the outline of everything you're wearing.
It's like an ultrasound.
Yeah, except they tune it so it stops at your skin, and so they just basically see you naked.
Oh, so like.
And if you didn't know that before, now you do.
Wait.
Yeah.
Not actually see
No, they're not actually. Just on a machine recreating it faithfully.
you.
Yeah.
It's the same thing.
What? No. Yeah. They have said that the machine will automatically like cover up private areas. Yeah, like an automatic censorship function. I'm sure that works faithfully all the time. Yeah.
What are they
So gamma rays are really, really high energy rays, very short wavelength. So the shorter they are, the farther they can penetrate. So a gamma ray will go right through you, which one, dangerous because if it stops anywhere and interacts with a bond, that could cause cancer like in the middle of your heart because it just went through you and caused it there. Or in the middle of your leg. It's not stopped by skin. It goes right through you. On the other hand, if it goes right through you and does no damage, woohoo! But getting shot at with a bunch of gamma rays, some of them are going to hurt you. I am a little bit more scared of the ones that are like alpha radiation. Alpha radiation is a really high, fast-moving helium particle that just hits your cells and causes damage. They're completely stopped by your skin, which means if gives you tons of skin cancer. It's really high energy, causes a lot of mutations. If you eat it, it will cause cancer all the way inside of you because you absorb all of the energy. None of it is escaping. Well, then just don't eat it, Mr. Neufeld. Yes, but when someone drops a nuclear bomb, and that's in the air and water and soil, you can't escape that. So that is a little bad. We used to have some gamma ray sources and alpha sources in the lab, but you'd have to write to the Nuclear Energy Commission of Canada and get licensing, and it was a huge deal, and so eventually we stopped doing that because you also had to be a physics teacher. I'm not a physics teacher. I'm not allowed. And I was the only one who wanted it. Now, it stops being ionizing radiation right about there. So any light you can see, right there, is not ionizing. You're fine.
You're gonna need to stop.
The UV light is just short enough to damage your bonds and just long enough that it doesn't go through you, so you absorb all of the radiation. So that is a sunburn. You absorb the radiation. It damages all the bonds in your skin. You peel, you blister if it's really bad outside. Or you go outside and you just do it on low power. You put on some lotion so that it doesn't get you as quite a high intensity, and you just tan, which is your body's way of saying, you're getting cancer, I should probably protect you, and gets darker to try and protect you from the cancer. So people invented tanning beds so that they can tell their body that they're giving it cancer on purpose so that it will get darker. Tanning beds they will often advertise that they're better than sunlight, they don't cause as much cancer. I don't know how that's an advertisement. Like, this cookie has poo in it, but this cookie has slightly less poo in it. And I'm like, I don't want to eat either cookie. Like, that's not a selling point. However, they have said that. Scientists have looked at studies to see if that's true, and it's not true. They cause cancer at the same amount you'd expect for an equivalent amount of sunlight. Now, that being said, if you choose to tan and you're increasing your risk of cancer, like, sure, there's people who go on international flights all the time. You're flying above the protective atmospheric effect. You're getting the equivalent of a couple of X-rays every time you do that. Do that enough times per year, you're increasing your risk of cancer. But we don't put people down for traveling a lot. A lot of people do some dangerous things because it's fun or they enjoy it, and it's mildly dangerous. Sure, if you like getting tanned, then you're trading off looking good now for being wrinkled and gray later in life. It's all good for you. Yeah.
Isn't it good for you, like a vitamin C or something?
Oh, you absolutely need UV. That's a really good point. You need UV to penetrate your skin and react with chemicals inside of you to create vitamin D. Except we get it in our milk because, especially here in Canada, we don't get enough sunlight to do that. We are too far north, so you either have to eat like raw seal liver and other such things of a traditional diet, lots of fish, oils, and get it that way, or you just like drink milk, because we put vitamin D in all of our milk, so that the theory is lots of people drink milk. If vitamin D is in milk, then lots of people will get enough vitamin D. Or you can just take a pill. So you can avoid the cancer and still get enough vitamin D if you're drinking milk. Yeah.
And also, why is the light in the tan blue?
To give it a visual effect, so you know it's on. A true UV source wouldn't be visible. Notice as well, blue and purple are right next to this, so it's easy to have a source that like overlaps all of that. Like red lights are more likely to be orange because they're emitting in that band. If it's emitting in this band, it's more likely to be blue or purple. Okay, now let's scroll up. Ionizing radiation, non-ionization sources. Cell phones are radio waves. Lead can block most of this radiation. It physically damages or breaks down cell DNA. I worked in a lab and we didn't do MRI or NMR or fancy x-rays. We worked with a type of gamma radiation that we would feed to the animals, and it would emit a gamma ray, and we would detect that. And so I had to build in my lab fume hood lead shielding, and then set up all the apparatus with automatic dispensers. And then once the lead shielding was made and it was all made up, I would walk away, we'd turn on the lab, would run itself, and all the alarms would go off because now the lab is completely radioactive. The year before, for whatever reason, some of the students decided to steal the lead blocks, and they were caught because it broke down their car. Lead is amazingly heavy, and they just lined their trunk with it in one layer, and that was enough to just shove the car down. They tried going, and they ground away all their support. Okay, how a virus can cause cancer. What? Oh, I didn't go down far enough. Oh, we can't forget Kiss. Because they're heavy metal. Chemicals induce mutations by attaching to the DNA. So rather than a light band hitting the DNA, chemicals attach to it and then cause errors during replication. I worked with acrylamide in the university laboratory. It was one of the most dangerous compounds I worked with. Where's the highlighter? There we go, highlighter. They had to have a particular area of the lab to put it in. We would add it to bacteria to induce mutations in order to study various effects. And it turns out, if you barbecue meat, that blackened portion of meat contains acrylamide. It is naturally made when you cook, especially if it goes black. And so that was only recently discovered, and they would then they said, well, this explains why people who have a diet high in this tend to get more cancers than people who don't have it. They're eating the same foods, where they get different cancers. Well, if you cook it till it's black in spots, you're actually eating more acrylamide. Acrylamide is also in smoke. Smoke itself contains a huge amount of chemicals that will cause cancer. There's many, many chlorinated chemicals. Anything with a chlorine on it, I would be a little suspicious of. There's a few of them not. There's a lot of artificial sweeteners that have a chlorine. Those ones are fine, but as you add more chlorines, and depending on the molecule, it can get worse. Lead, cadmium, cobalt are particularly deadly. Lead is a fantastic chemical. It's just sad it's so poisonous. And so any heavy metals in the environment can also be a problem. In areas of the world where there is a lot of conflict, can often get full of heavy metals. We like to make, as in the military likes to make their shells that they shoot out of things like tanks, out of purified uranium. So it's no longer radioactive, but uranium is even heavier than lead. So if you want to hit something hard, you hit it with a really heavy metal. And now you have uranium dust on the battlefield, which eventually gets into the food, because most battlefields turn out to be just some farmer's field. And so once the war is over, the people there continuously get poisoned. A carcinogen is specifically a chemical or element that causes cancer. And we were so close. I can't express to you how close we were to eliminating smoking amongst the youth. When I went to school, we had this smoking pit that was just open in front of the school, and then everybody would go there and smoke. And like 1/3 to 40% of the school, teenagers would just smoke there. And some of the teachers would join them, but they usually had their own smoking pit out the other side near the teacher's lounge. And a variety of advertising campaigns, awareness of the cancer it was causing, the problems it can do, the chemicals in it, the increasing legislation to remove these and make it harder to access. We've made it more expensive. And smoking rates amongst adolescents were actually on such a nosedive, they were predicting within 3 years, literally pretty much nobody under the age of 18 would be smoking at all. And then the industry invented vaping. And once they invented vaping, they reversed all that, and smoking is on the rise again. And by smoking, I mean regular smoking, because vaping can be expensive. Cigarettes are cheap by comparison. They're also easier to get in a lot of places. They first get you hooked on the nicotine for vaping. And then you chew a variety of products. Vaping does have less chemicals in it. They'll advertise it as being healthy. But it's a bit like the cookie example. It has less. It still has some. You are literally vaporizing a variety of chemicals. And the entire thing is that nicotine, as an effect, accelerates cancer growth. So if you give someone who has cancer nicotine, the cancer grows much, much faster. So even if it caused no cancer at all, any little cancer you get becomes a problem much more quickly. So Please don't vape. The people who study cancer are incredibly worried about it. Have you seen the advertisements? Old advertisements before they knew that cigarettes caused cancer? Well, they knew, but they didn't know. Have you not done that in English class? It used to be a unit. They have advertisements with doctors advertising how healthy cigarettes are. The industry had done studies, and they actually got taken to court over this. They knew it caused cancer, but they didn't want to tell anybody. And so they made sure to suppress that as long as possible, put out advertisements on how healthy it was, and the similarities to the current vaping industry is so eerily present. Scientists are like, vaping will clearly turn out to cause cancer. It has all these chemicals in it. We know it's going to do that. It takes years to prove it, like literally decades, because you have to show that people got the cancers. And in that time, they're going to have a heyday selling that to everybody else. That being said, vaping, much like tanning, if you really enjoy it and you're of age, there's nothing, you're not evil. You're just, you know, I like a cookie with a little bit of poo in it. Bacteria and viruses have been linked to cancer. Hepatitis B and C are known to cause liver cancer. There's a virus that will infect cats and a different one that will infect dogs that directly gives them cancer. They actually made a cancer cell that is a dog cell that can invade other dogs and grow and give itself and become cancerous. And they made it in the lab by accident. And they're deathly worried. That shows that could just happen in mammals. Humans are fairly prevalent. There's a large number of us, and the odds of one mutating eventually, a transmissible form of cancer, where you could have cancer and you just rub it on someone and now they have cancer, is one of the things they are seriously worried about. Yeah. Yeah.
You have cancer.
It's a bit like The Last of Us.
We have cancer.
How hard is it to find a cure for cancer?
How hard is it?
Yeah.
We say the word cancer, and the problem is, it feels. That view. There, perfect. It feels like one disease when you say the word cancer. Every type of cancer is its own disease. So you have to cure each one individually.
So in 2 days I'll be ready.
So yeah, it's a little difficult.
How much money has been put into cancer research?
Look. I mean, on the whole, we, as in Canada and the US, UK, tend to be worried about cancer. Why? Like, why don't we put our money into something that would save more people? Like, I don't know, malaria.
Is it because you can't really control cancer?
We care really.
Control.
Yeah, but we also can't control. More people die of malaria every year than cancer.
It's a mosquito disease. So you probably won't get it.
What kind of people die of cancer?
Any kind of
Oh, that's sorry. I looked at that and it was shiny, and I'm like, I can see right through it. Someone just put it in a case. Who did that? And no, it's just a mirror. I was looking at myself. The people who get cancer are like you. You get cancer.
Yeah.
Who has all the money?
Us.
Yeah, Canada, the US, UK, Australia, New Zealand. Countries that have money put their money in stuff that kills them. Countries that don't have money die of things of like dirty water, malaria, tropical diseases. And so we could save a lot more lives by putting it somewhere else. And there is a strong ethical argument as to why countries like Canada and the US and the UK and all those countries, we should put some of that money aside to help other people. Because if we have the money, we have an obligation not to just cure our problems, but to some of it into things like malaria. By the way, if it seems like, oh, we're never going to cure cancer, cancer treatment has come so far in just the last 5 years. There are some really good treatments that are coming out, and they just keep getting better all the time. The money is having an effect. It's just really hard to cure something that is yourself infecting yourself. It's like when you're trying to stop someone from hitting themselves, it's like they're doing it on purpose. That's your own immune system allowing it to grow. So a virus invades the cell, substitutes its own DNA to the host DNA, and then the host makes viral proteins. If the virus, so we have, say, A, T, T, C, C, G, C, 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 and then you have a virus, goes whoop, and say the virus, I don't know, is T, A, C, A, dot, 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 and it introduces right there. What kind of mutation is that?
Point mutation.
If it's right there, it's not a point mutation. It's not substituting. It's frame shift. First of all, it's putting itself in the middle, so it's going to disrupt the whole thing. And all of it's frame shifted. Even if you missed the beginning or something on it, it's shift the reading frame. It is a bad mutation. Now, it should theoretically come out later as well, but sometimes they don't. You can increase your risk of cancer by having certain types of genes. So there is an inherited portion. It's not that that is a cancer-causing gene. It's just that you have a gene that regulates growth, like everybody does, and you have a variant that needs less mutations to become cancerous than someone else. So it's just a higher risk gene. Doesn't guarantee you're going to get cancer, but it does increase the odds. I know someone whose parents got, both their parents got cancers in their late 40s, and it runs in both sides of their family. And so in university, they were looking for employment and jobs, so that when they had their children and they knew they were going to get cancer in their late 40s based on their family history, that their children would be well taken care of and they would be okay. They knew their lifespan would probably be shorter. They had a couple of variants running in their families that they were just highly likely to have. She had hoped her mom had passed it, but when her mom got cancer, then she knew it was definitely there. They alter cell division, gentlemen. They require several mutations. You don't get cancer from one mutation. You get it from mutations on top of each other. And I don't do a lot of detail on this. This is a Biology 12 topic. But your body has a lot of mechanisms to stop yourself from growing, because anything that's uncontrolled growth. So first of all, if your cells feel crowded, even if they're getting this signal to grow, they won't grow. They were too crowded, and they'll just stop. You need a mutation so that they like being crowded. You need a mutation so they continue to grow. If you're growing, you need a lot of blood. So you need a mutation that emits a growth factor that causes blood vessels to come to you. Those are all separate mutations. And so you need several of those to get cancer. But over the course of your lifetime, the reason that old people get cancer is not just it's not like, oh, they're old and their body's breaking apart. It's just that they've existed for a long time. We developed the technology to make you look like this and your bodies didn't age. You would still get cancer at about the same rate at the same ages, because it's the accumulation of damage. So even if your body remained young and healthy, you're still accumulating damage over time. Anything you can do to reduce your risk would help.
So is it just like unlucky?
It's just unlucky.
So like it's only a matter of time to
Yep.
get unlucky.
And it's lucky in the weirdest way, because if you talk to someone like, you should really fix your diet, you should eat more healthily, exercise is really good for decreasing your risk of cancer. Broccoli has bought up the entire anti-cancer industry, and it's like everybody's like, broccoli's so good for you. It's like the worst plant ever, but it helps eating well. And then some guy, he smokes a cigar several times a day. He weighs 892 pounds, barely moves, and just sits down and plays World of Warcraft all day, the original version, on his little tiny home server that he made. And he's going to live to 107 because he just didn't get cancer. Sometimes you're just lucky. And the person who runs every day and exercises every day and is a picture of health, all of a sudden gets cancer at 37 and they have to go in for treatment. It's luck. Now, can you decrease your odds? Yes, the person who runs every day has a good, healthy habits. Definitely, they increase their odds. But you can still just be unlucky. There's nothing that you did that you should blame if you get cancer. It is luck. There's a good luck component to it. Cancer cell is by definition an abnormal cell. It is a human cell. Your immune system is trained to develop it. You have probably actually already gotten cancer a couple of times, but your immune system has learned to identify it. So one of the mutations you need is a mutation that gives the cancer a way to evade your immune system. And they do it through a process called apoptosis. And apoptosis, and your cell comes along and looks at your cell and goes, that's a bad cell. And it looks the cell deeply in the eyes and it says, kill yourself. And your cell explodes. And that's how your body gets rid of cancer. How that works is that your cells are constantly producing garbage. And those, you know the walking machine I showed you that was like walking around inside the cell and it was carrying this big sack?
Yeah.
They carry those sacks that are full of garbage to the surface of the cell and they display it on the outside of the cell. And when your immune system comes around, it just feels the cell and goes, oh, that's garbage I know, and leaves the cell alone. But if it feels it and detects the wrong, like let's say in this class, instead of having the garbage cans taken away nicely, we just dump them outside the door. And every day the janitors look and go like, okay, yeah, that's the normal garbage. We'll take it. But one day they see a Shawnigan hoodie in the garbage. And the next day they walk by, they just throw grenades in the classroom. That classroom is now safe. And then another classroom would divide, and then you would have two classrooms. Take that one up. And your immune system is doing that all the time. It's protecting you, and it's getting rid of the bad ones. Cancer is a fascinating area because it is your own system, and some of the technology is coming better. Going through it can seem a little inevitable, but there's a lot of really good treatment now and ways to help. So, okay, that is all. You were supposed to have a PDF with all the answers on there. You were just going to copy it down. I probably took up way more of your time because I really like talking about cell growth and especially how cell phones don't cause cancer. You now have the rest of the time to work. Did I give you time? I didn't talk too long? Yes, so you have at least 15 minutes. Pardon?
What are we working on?
Anything you need to work on. There's some people I know that still have to hand in their labs. The worksheet for mutations that you shouldn't have been able to do last day because you didn't have this.
This one?
No, but that one too.
Did I see this one?
You got one last day when I was sick.
I mean, it's
That looks, it's got a picture of sunlight on it. Yeah, that one. This one?
CTS.
Isn't that it?
Oh wait, can I get one of those?
Yeah.
And then, I don't think I have it.
If you want to check, they're all right here. And I just noticed I had far less than I expected. The pile was way too small.
Yeah, I don't think you told us to hand it in.
Yeah.
I think I may have forgot. Yeah.
Oh, yeah, mine's at home. I remember.
Okay, just bring it in next day. I'm not going to get to marking that for at least 2 days. Oh,
You have extra.
oh yeah, just leave it. I'll put it in the box. Print it. I don't know where the pile is off the top of my head right now. I might have extra copies.
Is this the blood
But
type?
I think it's so long ago. They might have gone up.
Alright.
Leave it. That's fine. That's good. You're not going to hit your bets in the two? Okay, then good. If you know you did it right, you're all good. That's
Hell yeah, dude.
Name on it? Yeah. Says
Frick yeah.
Sorry.
Frick yeah.
Why does your sheet say Jessica Shortis? Where?
Oh, can I get mine on
This isn't your work, bro.
Ah, yes. Go back.
Okay, he's so lost.
That's a J, is that not?
Oh, you're lying.
Dyslexic, holy
Or
crap.
maybe your handwriting is
No, you
That's
just have
funny.
shit that says Isaac.
That says jazz.
It says Jazz.
Normally they have
I need
numbers.
the genetic.
I need this packet, yo. I just got the packet, yo.
Oh,
Where can I get the packet, yo?
have a
Ask Mr. You. Wait, you mean Travis?
Oh my god.
I didn't.
Wait.
I think you missed it too.
Oh,
You just
no
missed it.
way.
Oh, yes, we have to.
Let me look that up.